All right, pre-AP geometry students, we are going to prove triangles congruent through side. We're actually going to prove the side angle side theorem today, or postulate today, and or theorem, excuse me, and the hypotenuse leg theorem. We do these proofs and prove these things so that we can use them for our proofs later on. Just like when we talked about the reflexive property, once we have these in our arsenal, we can use these for our proofs later on. So we are going to go ahead and prove those today. Pretty simple concept, not quite as easy as the side, 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 but similar. First, let me direct your attention here to the two triangles. Notice in these two triangles you have two congruent sides. Okay, this side is congruent to this side here. This side is congruent to this side here. And then you also have an angle that's congruent to this angle. Notice that this angle is the included, what we call the included angle. It's the angle in between the two congruent sides. Okay, that's going to be important when we are proving side angle side. Okay, so now instead of looking for just side, side, side to be congruent, we're looking for two sides to be congruent and the included angle to be congruent. So two sides with the in-between angle to be congruent. Okay, and again we call this the side angle side. Okay, now let's go ahead and start proving it. What do we have here? Notice we have two triangles, theoretically, okay, or two parallel lines. We know they're parallel lines because of the arrows. You have congruent side DC, you have congruent side AB, and with these two parallel lines, how many transversals do we have? Okay, if you said 3, you'd be right, because this is technically a transversal, and this is a transversal, and then of course this is the transversal. But what we're going to find out is these two on the outside aren't going to help us as much as this transversal that cuts us in the middle. When we get that Z shape, this kind of transversal here, that's what's going to allow us to have the interior alternating angles and the exterior for on the outside. Okay. All right, so let's go ahead and start taking a look at this. We know that AB is congruent to CD. That's given. One of the things I want to point out too really quickly, I want to take a little brief pause from the proof, is that when you're doing proofs, one of the things I've noticed in class is a lot of you guys are doing the proof, but you're not actually drawing the picture or drawing on the picture. Guys, if you draw on the picture or draw the picture out and mark everything that it tells you, that's going to help you be able to see things a little better. It might help you jog your memory when it comes to these theorems and these postulates. So please make sure that you annotate your drawing. That's just part of the process. And I didn't specify that at the beginning. I thought that was more of a common sense thing. That's my mistake for that. Now I'm kind of stressing. Make the drawings and annotate the drawings. Okay? All right, so we have AB, and that's already marked congruent to CD right here. We also know that AB is parallel to DC. Again, that's given because that was already marked on our drawing. What else do we know? What else does that help us with? Look at angle ABD and angle CDB. So this angle here, up here, and this angle down here. Are these angles congruent? Yeah, absolutely. Why are they congruent? Right, they're alternating interior angles of parallel lines. Okay, since they're alternating interior, that's why that transversal right there is important versus these other two outside ones, because that creates the alternating interior angles. Okay, so that helps us because now we have a side and we have an angle and we have another side and another angle that are congruent. We just need to prove another side to be congruent. Okay, what side is missing? Well, if I need to make this the included angle, that means this side is missing. So I need to prove that to be congruent. Okay, so let's take a look. Is BD, this line here, congruent to BD? Yeah, absolutely. We just had a quiz today, and hopefully on your quiz you figured this out too. They're congruent because of the reflexive property. So now you have, and again I want to mark, I don't want to do that. I want to mark my segment congruent now. Now, there's nothing to be congruent with, but I do want to go ahead and mark it so I know that there's congruency now. If I separated these two triangles, I would have two congruent triangles because BD is congruent to BD. So now I have this segment is congruent and this segment is congruent, and then my included angles are congruent. This segment is congruent, this segment is congruent, there's my included angle. Okay? So now I can say that triangle ABD, and make sure you have the right order here, is congruent to CDB. Okay? Those two triangles are now congruent because of our side angle side theorem. And all you have to do is write SAS there. Pretty simple. And as always, if you have any questions, please feel free to come to tutoring. Ask me. Write those questions down. You'd be surprised. I do have a student that writes down like 3 or 4 questions, and she'll come in and ask me. And sometimes it's just questions about projects or homework activities, not necessarily about the notes. But it's good so you don't forget those questions. Okay? All right, let's move on to another one. Before we do that, I want to go ahead and one of the things I want to do is give you just some kind of tips for doing these proofs. First, you want to draw the figure and mark the givens. We already talked about that. And then in your proof, of course, you restate the givens so that you have that. Okay? And then, whenever we're trying to prove a triangle, we need to find 3 parts to be congruent. So now we have side, angle, side. So those 3 parts, 2 sides and 1 angle. That's 3 parts. And we also have our side, side, side that we learned in section 4.3. So those are the 3 parts that we need to be congruent. So we need to find them to be congruent and mark them on the figure. And then once I find 3 parts to be congruent, now I have 2 triangles to be congruent. Okay? So that's basically the way you attack these theorems. I'm sorry, these proofs. Okay, now we're going to talk about the hypotenuse leg. It's another theorem that we can use in order to help prove triangles to be congruent. When do we have hypotenuse? When do we have one of those? Are they in every triangle? Hopefully you answered no, because the only time we actually have a hypotenuse is when we have a right triangle. So this only applies to right triangles, because other than that, you just have 3 sides of a triangle. You don't have a hypotenuse for every other type of triangle. Okay? And how do we know where the hypotenuse is located? Which one is it? That's right, it's the angle, it's the segment or the side directly across from the right angle. Okay? Also, it's the longest angle. Okay? I heard somebody last year say something about it's the side that doesn't make, it's the opposite side, the side that does not make up the 90-degree angle. So these 2 sides make up the 90-degree angle. Okay? But one thing I want you to notice too about this particular diagram here is that you have a leg and a leg. Okay? I want to just kind of jump ahead to the future for a minute. When we talk about Pythagorean theorem, one thing that we need to understand is that some teachers teach that this is always A and this is always B, or vice versa. But a leg is just a leg. It doesn't matter which is which. Okay? The only thing that matters is differentiating the hypotenuse from the legs. Okay? So here we have a leg is congruent to another leg. We have our right angle, which are congruent to each other because of the right angles theorem. And then you have your hypotenuse congruent to the other hypotenuse. So with that being said, it's not side angle side, right? Because that's not the included angle. We don't know the angle measure here. We don't know the angle measure here. So it's not side angle side, but here you have leg, hypotenuse, and right angle. And because we have that, these triangles are going to be congruent. All right, so let's go ahead and do a proof. Here we have triangle FGH and triangle HEL, okay? Let's go ahead and do our proofs to prove that they're congruent. First, we know that F and G are congruent to E and H because that's given. Now, angle G is congruent to angle E. Why is that? That's right, that's the right angles theorem, right? All right angles are congruent to each other. FH is congruent to FH. Why is that? That's the reflexive property, right? Now, in this particular drawing, I should have hid this. I'm sorry, I hit that. That should have been hidden so that you know it's reflexive property. If I leave it up there like I did, that would have been given. So that was a mistake on my part, and I apologize for that. But that's actually a reflexive property. We've used that again in the last 3 or 4 proofs that we've done now. If it's FH and it's for both of them, the FH has to be congruent to itself, right? So now we have a leg, the hypotenuse, because that's the hypotenuse across from the 90-degree angle. Then you have your 90-degree angle. Here you have your 90-degree angle, the same leg, and the hypotenuse. So with that being said, you know triangle FGH and EH or HEF are congruent because of hypotenuse leg. The three parts are congruent: right angle, hypotenuse, and a leg. Always looking for three parts. All right, last but not least, let's prove these. Okay, we're given that BA is congruent to BC, so BA is congruent to BC. We're given that angle A and angle C are right angles. That's given. So angle A and angle C are congruent. Why? Well, right angle theorem again. BD is congruent to BD. Okay, why? That's right, reflexive property. So now we have a leg, right angle, hypotenuse, leg, right angle, hypotenuse. So triangle BAD is congruent to triangle BCD because of the hypotenuse leg. And that's pretty much it. Not much more to that. And here's your homework down here. It's your classwork tomorrow. Remember, if we're trying to get you out of class on Thursday with nothing to do. So if you want to go ahead and start this early, you can. So that way Thursday when you come in, we'll grade homework and then we'll do the rest. But that way you can kind of get out of class as early as possible. I mean, sorry, not early as possible. Get out of class with nothing to do. Okay, if you have any questions, come see me in the morning for tutoring. Again, guys, great job on your projects. I'm proud of you guys. Keep up the hard work. Good things happen when you work hard, I promise. Okay, keep it up. I'm proud of you guys for persevering. It's a tough class, but it only makes you better. I promise. Okay, if you have any questions, come see me. Great job.